All right, let's do some surface area of some spheres. All right, so first let's talk about what is a sphere? Well, my definition is it looks like a ball, right? It looks like the earth. So it looks like a ball. I am sure that is not the mathematical definition, but you know what? In my class, that's what I need you to know. It's curved, it looks like a ball. A radius. Now that's going to be the center to the edge, and you're used to 2D objects and not 3D objects. So this is going to be the center of the ball to the edge. Okay, I don't like to call it an edge because it's curved, right? We usually don't call curved things edges. But it starts in the center of the ball and it goes out to the outside curve of the sphere. Okay, so center of the sphere to the outside of the sphere. So I say center to edge. You know, however you need to remember it, that's fine. The great circle, it looks like an equator on the globe here. So right there's the great circle. So it looks like the equator on a globe. Looks like the equator on a globe. And it splits it into two pieces. Splits into two pieces. Now, those two pieces have a specific name. So imagine this great circle right here, the equator on the globe. You go slash, and you just cut right through this sphere. Well, when you cut through a sphere, it splits into two parts, and those two parts are called hemispheres. So they're just half of a sphere. Half of a sphere. Okay? So that's all the vocab you really need to know. Now, I'm not going to get into where they got this formula right here for the surface area of a sphere. We're just going to go with it, and we're going to use it on these down here. It says, find the surface area of each sphere and round your answer to the nearest whole number. Okay, so let's look at number one. On number one, we have to find the surface area. And if surface area is 4 pi r squared, we're going to have to substitute in for r. Well, 8 is r, right? It's a radius. So the surface area then would be 4 times 3.14 times 8 squared. Well, let's go ahead and square 8 first. So the surface area would be 4 times 3.14 times 64. Now, if I type all that into the calculator, 4 times 3.14 times 64, I get 803.84. Round to the nearest whole number. This 8 will bump that 3 up to a 4. So the surface area is going to be 804 centimeters square because it's an area. Okay? So you're just using the formula and you're substituting in and then you're rounding. I would like you to do 2 for class. All right? So go ahead and bring 2 with you to class. I want to see that one done when you come on in. Let's look at 3. Now, number 3 is different than 1 because this right here is not a radius. It is a diameter. And remember, the radius is half of a diameter. So if the diameter is 24, our radius is going to be 12 inches. So if the surface area is 4 pi r squared, we're going to substitute our 12 in for our r. So surface area is 4 times, now it says we get to round to the nearest whole number. So I'm going to use 3.14 in place of my pi. And I'm substituting in my 12 squared. Well, we have to work out what 12 squared is first. So this is going to be 4 times 3.14, and then 12 squared in the calculator will give you 144. Once you have that, we can type it all in. So we have 4 times 3.14 times 144. Now we're rounding to the nearest whole number. So this 6 right here is going to bump that 8 up to a 9. So 1809. 1809 inches squared. Just like that. All right? So make sure you do have 2 ready for class. If you need to rewatch this, you feel free to go ahead and rewatch it. I'm going to go ahead and move on to finding the surface area of the hemisphere. Now you would think that finding the surface area of a hemisphere would just be half of whatever you get for a sphere. But that's actually wrong, because what happens is, and you don't need to write this down, so I'm going to write it in red. What happens is, if we have this sphere that we break in 2, right? So pretend this is a sphere and I break it in 2. We have now exposed this new part, and that would be called the base of your hemisphere, okay? So because you've exposed that new part, you got a little extra, right? So you would take half of your sphere, but now you need to add in a base because you've exposed the surface, so you got to do the surface area of it. So if you do half of a sphere, and we know that a sphere is 4 pi r squared, and we know that the area of the base, it's a circle. What's the area of a circle? Pi r squared. And we work this out. This is 2 pi r squared plus pi r squared, which is 3 pi r squared. Now, I basically just showed you where this formula comes from. You're not going to have to do that for class. However, I do want you to write on your paper the area, the surface area of a hemisphere is 3 pi r squared. That's what you do need to definitely have on your paper there, because we're going to use that. I just want to kind of show you where it came from, okay? I'm going to actually erase that. If you want to rewind and watch that again, feel free to rewind and rewatch. So let's look at number 4. On number 4, we're going to use the formula. So the surface area is going to be 3 pi r squared. Well, right here is our r, so we've got that. We're good to go. So surface area equals 3 times 3.14 times the radius, which is 15 squared. And it does say we could round to the nearest whole number. So the first thing I would do is I would work out what 15 squared is. So 15 squared is 225 once we do that in the calculator. Now, since you get to round, I would go to the calculator. 3 times 3.14 times 225. And we get 219.5, but we need to round to the nearest whole number. So if this is 219.5, or 2119.5, sorry, I said it wrong. This is going to be 2120 when we round. And this is going to be meters squared. Okay? So I'm going to have you do 5 for class. So go ahead and finish up 5, bring it to class, and I hope you thoroughly enjoyed one of the shortest videos you have had to watch for me at all so far. So I hope you really enjoyed it. And you know, if you ever want to repay me, I love Starbucks. I'm just kidding. I just thought I'd add that in there. Okay, see you guys in class. Good night.